Build multi-region services, they said. It will be fun, they said. And it was. In this talk, I'm going to go through what we were trying to do by going multi-region, why we were trying to do it, and how we did it. But before we dig into that, I'll start off with a quick introduction. Who am I and how I got here? I'm Natalie Parker. I'm currently the Platform Engineering Tech Lead at Metapackers in the UK. My love for computers stemmed from my love of science. I did a physics degree, and I learnt to program in Fortran on my year abroad in Spain. When I came back, and I had to choose a master's project, I decided to do a computational project, and I discovered I love programming. There we go. Okay, third time lucky. I discovered I love programming even more than I love physics. I got a job as a developer, and I never looked back. I'm particularly interested in creating a DevOps culture and facilitating continuous delivery, as well as making sure that we use dashes and underscores in the right places, which seems to be a particular difficulty for many engineers and really winds me up, as my team will tell you. Currently, I lead the UK platform engineering team at Metapackers. I work with my fantastic Polish counterpart, Łukasz Ciechanowicz, and I really hope I said that right, because I had to get somebody to record it in Polish and practice it about 100 times, and that's the first time I've ever said it in public. Anyway, together we work to steer the team towards our technical vision. We do that by defining what our platform should look like and prioritizing what parts of it we work on. We also ensure what the team outputs is of the highest technical standards, and we mentor the team members to improve in the areas they want to focus on. So who are Metapackers? We're a tech company that makes delivery management software. So what does that really mean? We provide retailers with a single interface with integrations to over 470 carriers. We help retailers provide personalized delivery options so customers can choose between home delivery, pick up and drop off, and click and collect. We're the glue between carriers and retailers to facilitate the best delivery experience for the consumer. We have two main tech offices, London and the lovely Zielona Góra, and we're currently hiring at both. So if this stuff interests you and you want to get involved, please come and chat to me or Łukasz afterwards. You may even have already interacted with our products, as my mum excitedly found out when she saw a Metapack label like this one on a package at home whilst I was interviewing here. So multi-region, what do we mean by that? Now just to give you a little bit of context, in July 2018, Metapackers were bought by Stamps.com, an American company and the leading provider of postage online and shipping software solutions. Stamps.com were named second in Fortune magazine's top fastest tech-growing companies in 2018. So it was exciting news for everybody and set the stage for a strategic international expansion. But what does that mean for tech? We already have carriers and retailers that operate worldwide, as the previous slide about our company showed. And we already have offices across the world. Does it mean this? Deploy to all the regions? So specifically, our goal was to deploy an application stack in the US to accelerate Metapack into the US market. Now you may be thinking, one does not simply deploy into the US, in the same way that one does not simply walk into Mordor, as Boromir accurately pointed out. Now, as these plans were being made around November last year, you may also be thinking, is this how I spent my Christmas? Now, luckily that didn't happen, but before we go into the detail of how we did multi-region, let's take a minute to explore some of the reasons why people might want to go multi-region in general. There's many different problems and different ways to solve them, so I think it's always important to have clear on what your particular use case is so that you can optimize for that. So, why bother? Firstly, to improve latency, because as far as internet speeds have come in recent years, if we have two identical servers, one in the EU and one in the US, for people in the US, the request to the US server should come back quicker. Secondly, high availability. If one of the resources in your system breaks, with a highly available setup, there'll be minimum disruption, as there'll be other resources ready to take over the load. If you have an application stack already set up in another region, you can easily have more resources to use in the event of a problem, and it's less likely everything will fail at once anyway. Thirdly, disaster recovery. If a regional data center has a major incident, and you already have everything set up in another region, you'll be able to optimize how quickly you can recover. And finally, separate tenancy. We may want to have customer data and configuration for different locations kept separately, and this is often a legal requirement to keep data in the same country as the customers. So let's jump into a bit more detail about the tech stack at Metapack so you can have a better idea of what we were trying to achieve. This is a very simplified infrastructure diagram of some of the main parts of our stack when it was single region. We've got our delivery manager product, a Java web app running on EC2 instances in an ASG that spans several availability zones and it's behind a load balancer. This talks to a database on an EC2 instance which has a primary and a standby. And this product is a key entry point for retailers into our system. This calls what you can see as our carrier services application. That's a .NET app on Windows EC2 instances in an auto-scaling group behind a load balancer. And this is what facilitates our retailers connecting with so many different carriers, and it's the main piece of what the teams work on in Gelone Agora. We also have another customer entry point, our delivery options product, which is a collection of Java apps in Docker containers, also in an auto-scaling group and behind a load balancer. This talks to an RDS database. And our options delivery product talks to both the carrier service and the delivery manager, and it allows the consumer to have a personalized delivery experience by choosing the delivery option that works the best for them. So how to make this multi-region? This is the plan that we came up with. We were going to deploy key application services and databases in one region, in one US region, ensuring that customer data was kept separately to the EU region. Services where latency wasn't critical could remain in one region. So essentially what this means is that we would evaluate on a case-by-case basis what we were going to make multi-region, rather than just trying to do everything at once. Some services would get improved high availability as a secondary benefit. However, that wasn't our primary focus. So what would that look like? This is another very simplified diagram of our MVP architecture. We've got the delivery manager product deployed in both regions with a separate database and a separate entry point. Our carrier services application remained in Europe for now and would be called cross-region. Our options product is deployed in both regions, currently with a separate entry point. It makes use of AWS RDS cross-region replication, so the master, which handles writes, remains in the EU, but there's a read replica in the US, which the US application reads from. Now, the other reason for us taking an MVP approach, besides from it being good practice, is that we had a pretty tight deadline in the form of a demo at the Indonesia Delivery Conference. And as much as praying to the demo gods often works, we didn't want to chance it and risk another demo fail. So we covered the what we were trying to do with multi-region and why we were trying to do it. So I'm now going to go into the how and some of the most useful tools we used to get us there. But before we dig into that, let's just mention an important point. Part of the reason this was possible on the aggressive time scales without it being incredibly painful is because Metapack is in the cloud. We managed to deploy to another region very quickly without any engineers going to America and without it being incredibly painful, because with the cloud, it's just a few clicks or a few API calls, and then you have servers running in another region. So I'm going to be explaining how we did multi-region. Well, using various tools, but it's the fact that we're in the cloud that meant we were even able to do it at all. So firstly, a show of hands, who's heard of Packer? And who's used Packer? Aside from my team. So Packer's an open source tool from HashiCorp, written in Go, that simplifies building machine images across many different providers. Why do I like Packer? Well, firstly, it's cloud agnostic and works out of the box with Amazon EC2 and Microsoft Azure, which are the two most important ones for us. It works across Windows and Linux and allows you to use Ansible or another config management tool to do your provisioning, or even just Bash, which actually turns 30 today, so happy birthday, Bash. Packer provides a simple and unified way to create a variety of different base images, whilst giving the developers a degree of flexibility in their provisioning. We didn't want to have one tool which worked for half of our base images and not the other. And as it was so flexible, it also meant that we didn't have to worry about having to change how we build base images if we did decide to change how we did configuration management in the future. And it also helped with developer productivity, as if you're working on a Windows base image one week, and the next week you need to work on a Linux one. You already know the structure of how to do it. It's just a bit of different configuration. Another thing I love about Packer is that it automatically cleans up. Packer's tidy by nature, even if it fails midway through. So previously, we were having to create custom jobs to stop our Amazon account from becoming a graveyard of failed AMI builds. And as base images are something that we build regularly to ensure that we get the latest updates and security fixes, being tidy is really important. So also, testing infrastructure as code is important. And despite the uptake of many development style practices, with the popularity of DevOps, testing is still something which is often overlooked. However, there's no excuses with Packer, as it makes it very easy to integrate testing into your base image creation process. And finally, using Packer made it very easy to create AMIs in multiple regions. So let's look at an example. Packer uses JSON configuration files which specify what your base image should be like. Here you can see an example of an AWS Linux base image. There's 3 sections. Variables, which is fairly self-explanatory. They can be passed in on the command line or picked up from environment variables. We've got builders. This is where you choose what type of base image you want. So here we've got an Amazon EBS builder type. In this example, you can see we've set up a filter to pick up the latest source AMI, which you typically do to ensure that you have the latest security patches. You can see we've specified 2 different AMI regions, which are the different regions we want our AMI to be built in. And we've got the provisioner section. This is where you specify what you want to put into the image. There's 3 different types in the example here: file, shell script, and Ansible. What they essentially do is run an Ansible playbook against the image, copy the test scripts, and run the test suite. This is before completing the build. So if the tests fail, the AMI isn't built. Here we're using server spec, but you can also use things like Molecule to test your Ansible playbooks. And here we've got another example, building a Windows machine on Azure. You can see the same sections, the builders, and the provisioners, this time with Windows and Azure specific config. So something that wasn't clear from the examples is how to do regional configuration. For example, you have a different database in the EU and US like we did, so the connection strings are different. As Packer's literally copying the AMI from one region to another, how do you handle that? Well, you could have a separate configuration file per region, and then choose which file to load into your application on startup. With Amazon EC2 at least, it's relatively easy for the application to know which region it's running in, and therefore choose the correct configuration. Alternatively, you could have all of the configuration in one file, and your application choose which are the relevant items, once it knows what region it's in. However, this does raise a security concern of applications in one region knowing the configuration of applications in another region. So if one region is compromised, it could automatically expose the other region. So it may not be better to bake in your configuration and instead have your application fetch it at runtime from a regional specific location. But which of these options is best depends on your specific situation. But these are all considerations you should make when thinking about going multi-region. This is something that we didn't mandate as platform engineering. We let the application teams decide what worked best for them. And the good thing is, once you've decided what to do about your configuration in 2 regions and you're using a tool like Packer, it's very easy to expand to 3 regions. So, as mentioned, Packer works easily in conjunction with many other tools to provision your AMIs, and our provisioner of choice is Ansible. It's an agentless configuration management tool where you define the state that you want your system to be in YAML, and Ansible makes it happen. We use Packer to run our Ansible playbooks whilst it's creating our AMIs to ensure that everything is baked in and our infrastructure. If we want to upgrade anything, then we create a new server image and deploy a fresh server rather than trying to modify the existing one. This gives us more consistency and reliability in our environment and allows us to horizontally scale more quickly. To deploy these servers, and increasingly to deploy serverless components, we use something called Terraform. So another show of hands. Who's heard of Terraform? Now, who's used it? Okay, more than Packer. So Terraform is another HashiCorp open source tool that codifies APIs of many different technology providers into declarative configuration files, which you can then treat as code. One of the things I love about Terraform is its code reuse and standardization. So it's got shareable modules, so you can have common configuration defined as a module, which can then be shared between multiple teams and versioned. For example, an Amazon Elastic Container Service cluster. You may well have different engineering teams that want to have a similar ECS cluster with only a few different configuration differences. Now, instead of each team having to write their own CloudFormation templates, you can create an ECS module with a few parameters and everybody use that. If you then want to change that module, you release a new version of it so that any changes don't break other teams' work. And if you compare it to CloudFormation, which is its main competitor in the AWS space at least, Terraform really brings to life the phrase infrastructure as code, whereas CloudFormation was more, at least initially, infrastructure as configuration. So, as an example, here you can see how we do tags. Terraform has allowed us to create a standard tagging template so that every team can have the same set of tags without having to define them themselves. We then use a tool called Cloud Custodian, which checks that all of our cloud resources comply with our tagging policy, and if they don't, send a warning and then stop and terminate them. However, that's a story for another day. Back to Terraform. So another area where we've really seen the benefit of using Terraform, as opposed to cloud-specific services, is that we can define our whole stack in the same way. Terraform's got providers for New Relic, PagerDuty, Cloudflare, Akamai that we're using amongst many others. It even has some very obscure providers, such as a Domino's pizza delivery provider. The point being that you can write a provider for anything. So we have the flexibility that if we start using something that doesn't have a provider, we can always write our own. And we actually did this for the Kubernetes provider recently. There were some limitations, so we wrote our own provider to get around them until Terraform 0.12 came out, and then we could go back to the official provider. So we now have all of our infrastructure and monitoring and alerting all defined in the same format, in the same place, and versioned. Instead of creating your infrastructure as code and then setting up your monitoring alerting in the console, and then somebody changing the thresholds and you not knowing who it was or when it happened. And so one of the benefits I mentioned earlier is that with Terraform you can have shared modules and reuse code. However, this does create dependencies, which could be dangerous if you can change someone else's infrastructure without realizing. Luckily, Terraform understands dependencies. It's got two important concepts, the plan and the apply phase. To make an infrastructure change, you first make the appropriate code change. Then you run the command tfplan. This is essentially a dry run. It will tell you what will happen if you actually execute the change. So you get a preview of what's going to happen, and you can decide whether you want to go ahead with it or not. So this will show you that if changing the instance type of your EC2 instance, you're actually going to change everyone else's servers as well. Once you're happy, you do tf-apply, and Terraform will go ahead and make the changes, confirming once they're done. So far, so good. We were using some great tools. They allowed us to easily add in another region. However, we hit our first stumbling block. We had no network infrastructure in the US. Our VPCs in the EU had grown somewhat organically, just like this carrot. And just like this carrot, they'd be very difficult to recreate, as they weren't in Terraform or documented particularly well. So it wasn't quite as bad as physical server room spaghetti, but it still wasn't ideal, which I'm sure many of you know is British people's polite way of saying things are pretty bad. So what did we do? We started from scratch. This was one of the few things we had to completely engineer in moving to the US. As network design is something that's very difficult to change smoothly once it's in place, we decided it was worth the effort and time spent. It really made it clear to us that if we'd had to start building other aspects of the stack from scratch, just how unfeasible the timelines would have been. So this is what we came up with. There's a couple of things to notice. We've got a VPC per environment. This is so that we didn't have a dependency between the environments, and between the environment and the account it was in. So we could remove any environment without breaking others. We've got some platform services that are shared between environments, such as ELK and our CI server. We put these in a separate VPC, as we didn't want to have to create one per application environment, or put them into a particular environment. Amazon has a great feature called VPC pairing, which means you can specify a connection between particular VPCs to allow certain applications to talk to each other. You can now even reference the security group of one VPC and another, and share VPCs across accounts. This meant we could have different components in the new and old VPCs and migrate things over gradually without needing to do a big bang migration. And as you can see, this pairing also applies cross-region, which means we could create things in the US which could call things in the EU without having to go over the public internet. So, how many environments? Creating the VPCs brought up the interesting question of how many environments we should have. In the EU, we have quite a lot of environments, but replicating all of these in the US would be costly. So we decided initially just to have 2 environments, production and non-production, and see how that went. And so far, that setup's worked out for us. So now we have the infrastructure defined as code, the VPC set up in the US for us to deploy into. How did we deploy our applications across the regions? So this is how we were deploying things into the EU. We use Cloudbees, which is essentially Jenkins with enterprise support, and we run it on an Amazon Elastic Kubernetes Service cluster, as shown. We've got 3 permanent Cloudbees containers. Now, I've left off any Kubernetes-specific containers and the control plane out of the diagram to make it easier. We've got the Operations Center, which is managed by platform engineering, and has all of the Jenkins administration setup, such as users configured in it. We've got 2 team masters containers, one for the engineering team and another for the customer support team. We plan to separate this out further, with teams being more autonomous, but we're breaking out these masters as and when we need them, rather than trying to plan it all up front. But all 3 of these containers are just management containers and don't actually run any jobs. To run jobs, we've got several different types of agents. Firstly, for jobs that can be run in containers in the production account, as that's where our Cloudbees system runs, we've got container agents that run in the EKS cluster itself, for example, our seed job. Our seed job is a collection of Groovy scripts that call the Jenkins APIs to create all of the other jobs. We don't have any manually created jobs. To create a new job, you need to write a Groovy script and commit it into our Jenkins job repo. There's a commit hook, which will then trigger the seed job. Then Cloudbees will create a Kubernetes pod for the seed job to run in, and it will be automatically destroyed once the job is finished, which is why the seed job container in the diagram is kind of faded blue, to signify that it's not permanent. For jobs that can be run in containers but need to be in other environments, we've got on-demand EC2 instances in different AWS accounts that we run Docker and Jenkins jobs in containers. So what do I mean by an on-demand agent? In order to be cost efficient, we don't want to have build agents running for a long period of time when we aren't using them. Now, if you're creating build agents using infrastructure as code, then you can easily schedule them to start and stop depending on when your working hours are. However, this doesn't work particularly well if you have a globally distributed team, as you may have peak usage over a certain period of time, but occasional usage from smaller teams across the world, who will find it very frustrating if they have to start the build agents every time they want to build or deploy something. Jenkins provide an EC2 Cloud plugin, which will start up a build agent automatically when you start running a job. Now, as EC2 startup is long enough to be annoying if you're waiting on it for something, they also have a threshold you can configure, which is how long they will keep the agent up running when you're not using it for any jobs before it scales down again. We use Packer to create the machine images used by the EC2 Cloud plugin. And We've also got a couple of permanent EC2 build agents for things which haven't been converted to containerized builds yet. So, that's all very well for deploying things in the EU, but how do we do deployments into America? We've got 4 possible options. Create another Kubernetes cluster in the US. Use Amazon's Fargate service, which is essentially serverless container agents in the US. Use EC2 Cloud plugin agents deployed into the US. Or just use our EU agents. So now it's time for a bit of audience participation. We've got 4 possible options. Hopefully, this will load, and you'll be able to vote. Maybe not. There we go. Okay, so if you go to the link at the top and use the code, then you'll be able to vote on what you think we did. And the results should come in live as you start voting. Interesting, it's very close. Okay, so it looks like the audience think that we use AWS Fargate in the US. And the actual winner was continue with the EU agents. So, due to time restrictions, we didn't want to overcomplicate things. Creating another Kubernetes cluster in the US would be a maintenance overhead and would also be expensive, as although the containers the jobs are running in would be ephemeral, we would be paying for the cluster to be running most of the time. Fargate turned out not to be feasible because of a boring technical limitation. So the Fargate plugin uses a JNLP connection to connect to the build agent containers. However, this really doesn't play nice when your Jenkins master is also a container. And as many Jenkins plugins are created for the general use case rather than the specific Jenkins installations, such as the one we were running in a container, this didn't work very well. And we also weren't keen to introduce another way of having build agents, as we were already supporting several. Using the EC2 Cloud plugin to create agents in the US would have been an easy option if we needed it. However, after we reviewed what jobs we would be running, we found that actually using our existing build agents would be fine. It's definitely the most boring option to use existing agents, but it fitted our use case the best. If later on we do need to have separate build agents in the US, as I suspect we will, we can look at running the EC2 Cloud plugin in the US. Until we've got enough builds running there, it will really be worth having a separate Kubernetes cluster. So we've discussed what we're going to do about the build agents, but what about the actual deployment pipelines themselves? There's many different options, and I'll explore a couple here. So I've simplified the pipelines for the sake of them fitting nicely onto the screen in a visible way. So I've not included any testing, traffic canary, or rollback steps here. This first option is just to deploy to the regions one after another, but it does raise some questions. Which region should come first? EU was our original region, so perhaps that should come first. Or maybe the US, as any failures there would be less disruptive. Will the increase in time it takes to deploy to EU production be a problem, especially if you need to roll out something urgently like a security patch? And if test US deployments fail, then no production deployment can complete. If we bear in mind that some of our application dependencies only existed in one region, this could have an impact on our deployment pipeline. And the other thing is, if you expand to more than 2 regions, your pipeline is going to increase in length again. So another option is a parallel deployment to the different regions. After deploying to any single region environment, dev in this case, you fan out to your multi-region environments, and the rest of each pipeline is region dependent. However, this raises the question, should all production deployments be blocked if one of the test deployment region fails? On the diagram, production US can be deployed even if the test EU deployment fails. Now, a lot of these things which I've raised in the previous slides are application specific, depending on what services the application relies on, how long they take to deploy, and how easily they can roll back. Which is why it made sense for dev teams to choose their own multi-region deployment strategy to fit their application best. So here's an example. You can see here, we've got one Uber pipeline which covers all environments. Here, when you get to the prod deployment step, you ask for confirmation on whether you want to continue, as highlighted with my carefully drawn red circles. This sends a message to Slack, prompting the user to give their interactive input as to whether to proceed or not. And this is nice because it means you don't have to watch the pipeline, waiting for it to prompt you. Then if you go to the job itself, you can see the proceed and abort option. And on selecting proceed, the deployment goes ahead to both the EU and US regions simultaneously. And what you can't see here, because it was difficult to show it well in screenshots, is that the sandbox had already been deployed to in both regions. So the production deployment step would only be successful if the non-production multi-region deployment had already succeeded. And then, depending on whether the build is successful or not, we then get further notifications on Slack. And for some critical builds, we've also got notifications to PagerDuty, our event management system. And I think how we use PagerDuty was actually demonstrated in a great talk here last year by Pavel and Piotr. So we now know the what, the why, and the how. What next? We have our application stack deployed in the US. Are we done? Now, we may have deployed into the US, but how do we know it's working? If our services break, this can happen. So if Metapack services go down, there's a pretty big material impact, so it's crucial that this doesn't happen. Whilst working at Metapack, there's regular opportunities to go and visit the warehouses where our products are used to really understand what the effect is if there's problems with our services. As you can see in the photo, me looking overwhelmed by the size of the warehouse. Now in platform engineering, we've made a big effort at providing monitoring for free out of the box. All of our platform base images have the New Relic agent installed on them, and we've linked our New Relic account with our AWS account, so that everything in the New Relic account is already tagged with the region in it, without the developers having to do anything. This meant that identifying the region, from an infrastructure point of view, was relatively easy. However, some complexity came in deciding on how to separate our monitoring and dashboards by region. How do we know if our services are working overall? And if not, in which regions are they failing? Potentially adding a second region would triple the number of dashboards and alerts, as you may want to see each region separately, plus a combined view. We would initially have a lot less traffic in the US, so would we want our alert thresholds to be the same, when a couple of slow requests in the US may be more likely to wake us up at night? Having set dashboards and alerts would be particularly important during deployment, as otherwise we could potentially have a deployment to the US that was broken, but may not be picked up by a general monitoring, as our traffic to the US is much lower. We essentially had to evaluate all of these things on a case-by-case basis, as there wasn't a one-size-fits-all approach. Our main monitoring tool is New Relic, and in some cases it was useful, and in other cases not so much. So for infrastructure monitoring, as I mentioned, everything was already tagged with the region because of the AWS integration. And so we could easily add a filter to the dashboards, so they could be multi-region. with the flexibility to filter on a particular region when necessary. The New Relic application performance monitoring wasn't so great out of the box. It didn't by default give an aggregated view across the regions. It's a common use case for us to have 3 instances of an application running in the EU and 2 in the US. So being able to group the applications by region to understand their performance was really key. In order to do this, we added a region label at the application level so we could easily roll up by region to pick up on regional problems more easily. We also ended up adding the region to the host name so that we could more easily narrow down to a particular region. So we have our stack in the US. We know it's working. Is that the end? Well, as Gandalf the White once said, no, the journey doesn't end here. The next things we're now thinking about are how to do geo-routing so we can more intelligently route our traffic between regions and reduce latency and improve high availability. We've also got some work remaining to ensure parity between our regions. And perhaps now we've done it once, will we even look at deploying to another region? Who knows? However, as well as looking forward, I think it's important to look back and think about what we've learned in getting here. So these are the main pieces of advice I'd give to anybody who is considering going multi-region themselves. Infrastructure as code using the right tools is invaluable. Now we all know having your infrastructure defined as code is a good thing to do. However, it soon became very clear that it was one of the key things that made this project possible. We chosen Packer and Terraform well before multi-region even became a consideration, but having both of those products, a key part of our existing toolset, really helped us deliver smoothly and on time. Solve your problem. Compromises will have to be made, so be sure of what you're optimizing for to ensure that you make the right choices. You can't optimize for everything. There's many reasons to go multi-region, but it's difficult to have it all. We could have tried to replicate absolutely everything in the US in order to have a very highly available setup. However, that would have been very expensive and meant we missed the deadline. So by always having clear what the problem is you're solving, that helped us make the right decisions along the way. Strike the balance between making improvements where possible and not missing the deadline whilst chasing perfection. The US region was new and clean, no legacy, no tech debt there. The temptation was to try and make everything absolutely perfect. We had a lot of debates internally about what we should improve and what we needed to keep the same. And it was a difficult balance, but I think we got it right. There was also the reality that anything we did in the US, we would also need to do in the EU, as it was important that our regions were the same in order to avoid any operational headaches down the line. For example, we didn't want to come up with an amazing VPC plan that would only work in the US and then have to maintain 2 different network infrastructures. And consider future problems you may have without over-engineering for them. So it's important to assess the difference between what your current needs are and what your future needs are. It was tempting when considering how to do multi-region deployments to deploy Kubernetes everywhere, or come up with a complicated solution to run builds all over the place. But when we took a step back and assessed what jobs we were trying to run, we found out we didn't need to. And as much as I love shiny new tech, if you have a hard deadline and it doesn't provide any business value, there's probably better ways you can be spending your time. Metapackers is shaping the delivery landscape through our products, and it's important that we stay nimble in our use of the right model tools to deliver this promise. Dziękuję.